welcome to the Supply Chain Security and Reliability webinar. I'm Sean Anderson, Field CTO for Nearform, and happy to welcome Kit and Priya, who are going to give us a nice discussion on security and their favorite attacks, which is kind of a scary thing to hear. But this webinar is being recorded, and we will be able to do questions and answers at the end. But also, while we're going through the presentations, feel free to ask questions in the chat windows, and we will get to those at the end as well. So with that, I'm going to turn it over to you, Kit and Priya, and welcome.
Thank you. Thanks for having us. Hi, everyone. My name is Priya. I'm a software engineer at Chainguard. I work on a bunch of really fun open source projects like Treestore and Tekton, kind of just working on supply chain security in my day-to-day.
And hey, everybody, Kit Merker here. I'm the COO at Noble9, and I get to work on cool stuff like reliability and service level observability, SLOs, and very excited to talk here. But Priya's going to go first. So we're going to talk about supply chain security and reliability. She takes security and I will take reliability, and hopefully it will all make sense to you. So shoot some questions in the Q&A and we'll be happy to answer them at the end. Let's go.
Cool. So why are we talking about this? So you can see from this graph from Sonatype from 2020 that supply chain attacks have really increased in the past couple of years. And I feel like people kind of always knew it was important to secure their supply chains, but in the past year or two, there's been an executive order around supply chain attacks, and there's been a bunch of attacks in the mainstream media as well, which has really kind of highlighted an urgency around securing your supply chain. So I'm going to talk through a couple different attacks that have happened in the past couple of years that you probably have heard of, and kind of just discuss how, like, the interesting thing about supply chain security is that there are so many different risk areas and different ways that you need to mitigate your supply chain. So let's jump right into some of the examples. So I think the big one that everyone kind of remembers is SolarWinds, which happened early 2021. And that attack really sort of sparked this conversation around supply chain security, and really kind of made people take notice of it and start evaluating their own supply chains. So for those who might not know or might not remember at this point, this was actually a build system compromise. So basically, attackers were able to hack into a SolarWinds build system and inject malicious code into the software that they were building. The software was signed just as it normally would have been, and then distributed to end users who had no way of knowing that there was malicious code in the software that they were running. The interesting thing about this attack is that kind of like normal methods of, or like kind of common methods of securing your software, like signing it and then verifying it, wouldn't have actually helped because it was actually the build system that was compromised. So this kind of attack really highlights that it's becoming just as important to secure your build system as it is to, secure your production environment. Cool. So this one is kind of an entirely different threat model, which is really interesting. So basically the story around this attack, there was this crypto app called Treestore on the Google Play Store. And I guess some bad actors decided to mimic it and create their own bad version of this app. So their fake Treestore app looked almost exactly the same. The only difference was that it was technically issued by a different developer, but that developer was made to look really similar to the real thing. And the crazy thing is that when people would search for the app in their Google App Store, the real thing would come up first in the search results, but then the fake one would come up second. And it ended up being downloaded 1,000 times before it was removed from the App Store. The app, once it was downloaded, people would log in with their usual credentials, and then the bad actors would have access to the credentials and start stealing their crypto. So I think the interesting thing about this is it really kind of illustrates that we need some sort of end-to-end, mitigation in our supply chain so that even end users have a way of verifying where their software is coming from and kind of deciding for themselves if they find it trustworthy or not. And then lastly, we have kind of an attack that was aimed at dependencies. So this one happened early this year. an open source developer, actually a maintainer on the npm colors package, sabotaged it themselves by adding an infinite loop into the code. Instead of merging this code into source control, they actually just pushed the package to the npm registry manually. And because of the way that npm dependencies update, it'll just try to update a dependency to the most recent version possible. And so this update was actually downloaded by thousands of projects. And this library is actually downloaded, I think, 23 million times a week. So tons of people who were depending on this, either directly or just indirectly, were affected. It kind of like, to me, this illustrates, one, that it's important to know what dependencies are in our code and where they're coming from. It also kind of highlights how important open source is in securing our supply chain, because most software does depend on some open source code. And yeah. So kind of bringing together some of these examples, we have this end-to-end supply chain, starting with the developer on the left, moving into our source control, our build system, the package repository where the software would be distributed, and the dependencies that go into the build. So we have threats like submitting bad code or compromising source control, kind of similar to the npm colors package example that I just mentioned. Then there are all the build threats, like modifying code after source control, somehow compromising the build platform, like in the SolarWinds case, or just bypassing CI/CD altogether and somehow pushing software directly to a package repository. Also, what happened in the npm colors case. And then there's also things around dependencies, like using a risky dependency, not necessarily knowing where your dependencies are coming from. And so it's really important that we kind of secure this supply chain end to end. And I think it can be really intimidating because there are so many different risk areas in the supply chain, and they each need to be mitigated in a different way. So it can be difficult to know where to start, and also difficult to know how to address each of these different problems. But luckily, you don't have to figure it all out for yourself. So this is where Salsa comes in. So it's not really a condiment in this case. It actually stands for the supply chain levels for software artifacts. Salsa is basically a security framework that you can use to kind of ensure the integrity of your supply chain. You can kind of think of it as like a checklist, where the more things that you check off, the more secure your supply chain is, and the more confidence you can have that you have mitigated a lot of the risks that we just talked about. So it's a security framework to help make build artifacts tamper resistant. The interesting thing about Salsa is that it has some requirements around how your software is built, but it also requires that you include provenance, which is kind of a metadata alongside that software artifact. So provenance basically includes details about how build artifacts are created, who created them, potentially even like what went into them, what steps went into building them. And the idea is that end users, when they get their software artifact, can have some information around how it was actually built and make a more informed decision around if they think that it's trustworthy. So what actually is the Salsa framework? So it was designed over the past couple of years based on industry consensus, and it ranges from level 1 to level 4. So level 1 is meant to be the most achievable level, and then level 4 represents like an ideal end state for your supply chain. So at level 1, there's only 2 requirements. It's meant to be very achievable today. All it requires is that your builds are scripted and that there is provenance available. So there's like something that will tell people how your software was built. At level 2, we start to add in like a few more requirements. It starts to get, a little bit more secure. So we add in requirements like having your code and version control system, like GitHub, which honestly, hopefully you're already doing, and that's like an easy one that you can check off. It also requires that your builds are in a proper build system. And this is kind of where more requirements around provenance come into play. So it's no longer sufficient that provenance just exists. We also need to have it signed so that end users can verify it. And it also needs to be created by a build system. So no more generating your provenance by hand, although hopefully you were never doing that because that sounds really painful. At Salsa level 3, we start adding in some more resistance to specific threats. So this includes security controls on your host where you're building your software, and also has this requirement for non-falsifiable provenance. So the idea is that not only is provenance generated, but you can prove that it actually can't be tampered with. And at Salsa level 3, end users can get your software artifact, take a look at your provenance, and be completely confident that that provenance is correct. And that's exactly how that software artifact was built. At Salsa level 4, like I mentioned before, it's still currently an ideal end state. I don't actually know of any build systems where you can achieve Salsa level 4 yet, but we're definitely working towards it. That's kind of part of my job. But at Salsa level 4, it starts to require things like hermetic builds, which means that your software would be built without network access to prevent any like malicious dependencies or malicious code being pulled in at build time. And it also requires two-party review to kind of like distribute trust amongst multiple maintainers. So the idea is that one maintainer trying to sabotage the package wouldn't be able to if two-party review was in place. So how can you get started with Salsa? I just threw a lot of information at you. What can you actually do to start supplying your supply chain? So I would head over to the salsa.dev website. There's a really useful getting started tab, which will kind of guide you through starting to achieve, try to figure out what the requirements of each level are, and you can sort of decide which level is the one for you and for your supply chain. The good news is if you're already using a couple of these really common build systems like Tekton, GitHub Actions, Google Cloud Build, or Azure DevOps, there are already a lot of tools out there that you can just sort of install and start generating provenance for your builds and start achieving certain Salsa levels. So yeah, definitely check it out. I'll throw it over to Kit now for the reliability part.
Thanks, Priya. So one side of the equation here is making sure that the supply chain is secure. The other side of it is making sure that the supply chain is reliable. And this is where I want to share another scenario that happened in the supply chain in the world. And this has to do with Ruby on Rails. What happened is a sub project of a common library, a very common one, was actually moved from one form of license to another. And so it was identified that this project was this library, this dependency was a GPL, and it needed to be MIT to be part of Ruby. GPL, if you're familiar, is a much more permissive license. And what this did is not only did it cause the build systems to break for hundreds of, I think it was even thousands of projects, but actually it says thousands here, hundreds of thousands even, like it's 2 orders of magnitude more. Hundreds of thousands of developers were impacted by the fact that it changed, and they had to fix it in their build system. And then one step further, they even needed to worry about the impact of the GPL on the source code that they were using that they thought was safe because of the licensing of Ruby on Rails. Now, there's a couple of different issues to unpack with this scenario, but the bottom line of it is that you have dependencies as part of your supply chain. And if you think of your supply chain now as an extension of production, right? You have this production environment that you're deploying software to. And now, because we need to be able to update our systems much more rigorously and more frequently, the reliability of the underlying infrastructure, from how you bring in external source code, how you manage your internal source code, your artifacts, and your build process, and now with the new Salsa requirements on top of that, all of that system is actually an extension of production. And the reliability requirements, as a result of that, go way up. So what I want to show you is, or what I want to think about, is the questions we need to ask to make the supply chain reliable, right? First is to think about this supply to delivery process as a repeatable process, something that we can repeat over and over again and expect very similar results. On top of that, if we do it 1,000 times, 1 out of 1,000 times should fail. And maybe it's 99.9, and maybe it's a higher or lower depending on your specific requirements. But the point is that we want to see a success rate on that supply to delivery process that's very high and very automated. We want to make sure that when we have failure states, which always occur, you can never build a perfect system. We want to make sure that we have recoverability in all those different cases. We have a way of measuring it, monitoring it, and working around the failure states, and that we can recover that system in a repeatable way, and we have trust in the risk management of it. And that's going to get us to a confidence that we can deal with unexpected circumstances. A lot of these, everybody I think is familiar, a lot of these security things happen at unexpected times. The hackers do not work around our schedule and do it conveniently. They do it at the worst possible moment. Murphy's Law comes to bear. So what we want to do is we want to sweat in practice so we don't bleed in battle. We want to be prepared for when something unexpected will happen. And then we can be confident that our supply chain will actually work in those conditions because we've put that to the test, just like we do with our production systems in normal computing. So SLOs, I want to introduce this concept. This is a general purpose tool for measuring the reliability of systems, okay? What they are is they're reliability goals for any system, but they have a little bit of wiggle room. And the wiggle room is what makes them such a powerful system. Instead of thinking about reliability as a pass-fail, as either it's reliable or it's not, instead we can think about it as a spectrum. And so if you think about a spectrum of reliability, on the low end, below some certain threshold, we can call it an SLA, your customers will leave you, right? Whether they're using your service or if you're not able to deliver what you need to deliver, customers will leave and choose somebody else. And in a lot of cases, you may even be stuck with financial penalties for violating SLAs that you might have signed with your customers. Everybody kind of knows that this below this certain level is bad. But on the other end of the spectrum, as we try to achieve 100% reliability, making things perfect, we end up actually over-engineering and creating gold-plated infrastructure and slowing the team down. And this is what also to be avoided. Anytime you say, okay, we need to make sure this is 100% works every time, you're going to expect to spend a lot of money. Every 9 you add to your goal is another 0 on the bill, if you know what I'm saying. So what we want to do instead is define a service level objective, an SLO, that is actually based on customer happiness and the requirements of the system. So if we can slightly overachieve it, we move from being unhappy to happy, and we're delivering what we need, the vast majority of the time. And our team goes from being burnt out, chasing the pager, to being productive because they know what they're focused on truly matters. And this introduces a new concept called an error budget, what I like to call wiggle room. The error budget is the gap between whatever that goal is we set, the SLO, and 100%. So if I say, 99% is my SLO, then that means, or 99.9% is my SLO, that means my error budget is 0.1%. And what's cool is that with that error budget and thinking about measuring that error budget, we can actually understand better if our system is trending toward violating the goal we set for ourselves. So this is a general purpose framework for measuring the reliability of systems. What I want to do now is apply this to the supply chain. So just like Priya just laid out, we can take that same exact framework for the threats, and now we can overlay it with SLOs. We can think about setting specific goals for the end-to-end process, right? So our supply to delivery from developer to consumer. We want to set goals around that, around the repeatability, the availability of it, the latency of that process, the throughput of that process. We can set goals for it, which basically say what percent of the time or what percent of the events are successful. That's what we want to measure on an end-to-end basis. That gives us this big picture view. Then we can think about internal SLOs. So inside of this process, there are sub-processes. The build and package steps each have their own sub-processes, which we can measure. So we say we do 1,000 builds. What percentage of those builds executed without failure? What percentage of them completed within different percentiles of performance? So within, maybe 15 minutes versus 20 minutes versus a few hours, depending on your build system. And you may have sub-processes that are on the order of magnitude of milliseconds or seconds. All of those can be measured as SLOs. You just have to decide which ones have the most meaningful impact to the process. And then finally, thinking about the dependencies. So, the external dependencies you have. Maybe you have artifacts that you're collecting from the internet, open source packages, et cetera. Assuming you've got the security in place and you've got the provenance figured out, like Priya mentioned, we also want to make sure that those systems are available to us so that they're not breaking our build. So measuring our external dependencies and understanding the availability and performance latency of those systems is important in understanding this overall picture. And by having these different SLOs at both the internal, the external, and the end-to-end level gives us a clear picture about where the problem is, right? We always talk about being, no blame in a postmortem, but actually in the heat of battle during a 0-day or a supply chain outage, we actually want to know what system to blame, right? We want to know what system is broken so that we can go and put our energy toward resolving that in these situations. So thinking about the supply chain as a production system that has service levels that need to be measured, in addition to the security of it, is how you're going to build a resilient supply chain that actually provides the value to updating production. Reliability is a complex area. It's a very difficult thing to think about, to make investments around, and also it always feels like a tax. Security and reliability are always getting pushed off as necessary evils, and people like Priya and I, we spend a lot of time thinking about security and reliability and how to get people thinking about this. But there's some key questions you want to ask to drive the reliability. First, what are the end-to-end internal and external systems that need to work? How often can we accept failure? What happens if they don't work? what action will you take in different failure conditions? If you can't tie action to it, observability, I like to say observability without action is just storage. We don't want to just collect data about what's going on. We want to make sure we have a plan for how we're going to take action, whether that's automated or human action, right? And that's the next point, which is whatever we can automate, we should, up to the point that the automation becomes a distraction and becomes a system of its own. So we want to make sure that there's humans in the loop. We want to be thoughtful about when we wake them up, when we page them, how to avoid making it noisy. And the great thing with SLOs is they allow you to do that. By setting error budgets, you can ignore small amounts of noise and really focus on the things that are not recoverable. Building a system like this, there's like backups are worthless if you don't restore them, right? We need to make sure we actually test it. We need to test the reliability of the system and push it to some sort of limit to understand if our supply chain is resilient or if our supply chain is brittle and potentially a risk to our production system. Thinking about the supply chain as part of production, right? Thinking about this as part of your testing, your certification, your annual business continuity planning. Maybe you do it more often than that, but all the things that go into making a system resilient and ready for being under load and under difficult constraints. This should all be part of thinking about that supply chain. So don't just look at it as this, how do we make it secure, but also how do we make it reliable? And the combination of the two will give you a competitive advantage because now you're able to quickly and confidently deliver to production, which is what we really need to be able to do. Priya, you want to wrap us up here?
Yeah, totally. Thanks, Kit. So basically just a quick recap of everything we already talked about. Like we said, software supply chain attacks are becoming a lot more prevalent. They're all over in the news these days. There's a lot of different risk areas, a lot of different ways that your supply chain can be attacked. And it can be really intimidating to try and figure out where to start securing your supply chain. But it's also becoming more and more urgent that you start doing it. It's like really clear that the distinction between your dev environment and your prod environment is kind of going away. Like it's now just as important to make sure that your dev environment, your build system is just as secure and just as reliable as your production system. You can use SLOs to kind of ensure this reliability, and you can start using the Salsa Framework to get started figuring out how you want to secure your supply chain and how secure you want it to be. Mostly it's important to just set realistic goals tied to specific automation so that you can act when something goes wrong as quickly as possible. Just be safe out there. Thank you so much for coming. I think
so a couple more things before we go. We got to give a shout out to Priya's colleague, James Strong, speaking at SlowConf next week. If you haven't registered yet, we've made it really easy for you. You can pull out your phone right now and point it at the QR code and it will send you to the registration page. SlowConf is a completely virtual, completely free, attend while you work event happening next week worldwide on 5/9, May 9th. And it's going to be really exciting. We have 60 speakers, over 9 hours of content, amazingly. But you can go at your own pace. It's all snackable, 5 to 10 minutes in length, and it's all asynchronous. So anyway, join us at SlowConf next week. It's going to be fun. Priya, you're going to be there, right?
Oh, yeah, totally.
Yeah, awesome. And that's it. Questions? Thank you very much.
I have 3 questions, actually. That was great, but I don't know if anybody else has questions. I tend to ask really dumb questions, so don't judge. But
awesome, let's hear it.
Well, one of them is just simply what are some of the most common threats or mistakes that you see people make that maybe, even if they did just one thing or, turn on some level of observability, is there something that you see is the common first step towards getting up that salsa scale that people can address?
I think like maybe just kind of starting to, it's hard to say because it really depends like case by case, but I think the first step for a lot of people is evaluating the build system they're currently on and then deciding if that build system can get them the level of security that they need. So I've seen a lot of people sort of considering it's hard to migrate, but kind of considering if they actually need to start moving over to like a new build system that can help them achieve those higher salsa levels if that's something that they desire. I think really the first step is just sort of evaluating where you at, and then if you're comfortable with that or if you feel you need to be somewhere else.
So it sounds like just simply the awareness that you should attend to your build system is is a big part of it. Because I know
Yeah.
that's what I've missed. It's like, to me, the build management and supply chain is a means to an end, but often you don't even think about the vulnerabilities or issues that may come up.
I'd say one of the I think one of the challenges here, there's obviously technical challenges that are there, but one of the big problems I've seen is just getting the management buy-in for investing in this. It always feels like security and reliability or something we'll take care of someday. It's a tax, it's a cost. We need to ship features. And what I've seen more sophisticated organizations starting to do is to push reliability initiatives and security initiatives where they actually create space in the feature roadmap specifically to address these things. And if you can get senior management to understand that, look, we got to take care of our risks too. It's not just about shipping capabilities. The security issues that we're talking about in some cases are existential to these companies. And if you can get people to understand that and then also have a solution and a framework for getting there, that creates the space. And I agree with Priya 100%. Number one, you got to understand where you are. You can't improve what you can't measure. So getting the basic stuff figured out, finding the low hanging fruit, and getting the management support. That's really, I think, the key thing you got to do.
That makes sense. So Peter asked a question in the chat. Are there any managed services that could have prevented a malicious NPM module attack, and how do they work?
I'll take this one. Honestly, I'm not totally sure if there are any managed services that could have prevented a malicious NPM module attack. But I think this is like one of those things where if you have been following sort of the Salsa guidelines, the idea would be that at every step, you have some way of sort of verifying that the software had gone through that step. So kind of in the attack that I had mentioned earlier, a package was pushed directly to the package manager rather than going through like a review process in version control and then going through a build system and then being shipped. But if that repository had only accepted packages that had been signed by the build system, then that wouldn't have been possible. So I think sort of just kind of making sure you have that security at every step in your supply chain is kind of how you can get around some of these kinds of things.
Yeah, I would add to it. So there's a number of companies out there that are offering repositories and security solutions. So think like you got your JFrogs and your Sneaks and all these companies that have package security scanning and things like that. But there's a buyer beware or a consumer beware kind of attitude, right? You want to protect your system from the bits coming in. You got to think about a quarantine strategy and other things like that. But the other angle, just kind of a meta point, is that all of these attacks, whenever we see them, they're always sort of obvious in hindsight, but they're always a surprise when the first time they happen. And so the other part of this is making sure you've got a good response plan in place, right? You don't know what's going to happen, but if you have the kinds of infrastructure where you can roll back, you can respond, you've practiced, the kinds of response you would need, and the team's looking out for it, then that's the next best thing, right? First is like the defensive move, which I think we all want to get there. But the second is a responsive move, right? And so the more you can observe and respond, and the faster you can do that, and the more trained you are in doing that, the better.
Definitely. I mean, I think the thing is it's important to try and mitigate risk and secure as much as possible, but things happen. And so it's also important to be able to recover from them.
So I have one more that's kind of a little on the edge, but I was interested when you were talking about like the license management and things like that. And it seems like there's kind of a strategy for dependency management that's not just looking at the dependencies themselves, but maybe their behavior or the flavor of license, especially if it's open source. Are there any other kind of edge dependency management issues or thoughts that you consider as part of the strategy for that as you're defining that?
Well, I'd say, I mean, there's a need now, especially at enterprise software and cloud, the complexity of our software and the reliance on open source. Open source is kind of a double-edged sword. On the one hand, you get a huge advantage out of it from the work that other people are doing, but the disadvantage is that it's less in your control, and things like this with license compliance and other things can really hurt your commercial strategy. When you go to sell software to an enterprise customer, or you host it in a cloud provider, or you sell your company, and you have to go and prove that you really do own the IP that you think you do. It is a really important thing. I do think that the supply chain at the design level, thinking about what licenses you're going to accept, and then how do you enforce it, how do you build quarantine protections and rollback and other kinds of defensive strategies in place, and having a thoughtful plan for it. Because the biggest risk, I think, in some ways is having developers. You want to keep them productive, but they don't always know the rules of the road, and they may be trying to solve a problem. I'll tell you a great example of this, right? One that I have run into in previous projects I've worked on. Going to Stack Overflow and copy and pasting the code into your software. This seems like such an obvious and easy thing to do, but all the code snippets on the internet are licensed, right? Like if you go to Stack Overflow, there's actually a license for all that code snippets, and people who are doing M&A projects, buying companies, spend a lot of money scanning for snippets copy and pasted from Stack Overflow, for example. And that may be an obvious thing, but getting your engineers to think about these things that may impact them they're not aware of, that's one part of it. And then having these defensive systems in place so that they don't have to think about it. Having the scanners, having things like Sonar Source to do code quality and clean code, having tools like Salsa, having SLOs in place, having all these different capabilities starts to build a cohesive system, and then that becomes more secure and reliable than any one individual's discipline or knowledge could possibly be. And I think that's the important part, is there is individual responsibility for the engineers and the CTOs that are thinking about this stuff, and then there's this systemic responsibility to build this supply chain and to think about the supply chain as a system that is architected and is measured and is improved over time.
That's great. The last question is, how do you suggest incentivizing teams to use the Salsa framework? Is it just
some sort of Taco
self-evident?
Tuesday? Taco Tuesday would probably be a good way to go. I don't know.
Well, it's Cinco de Mayo today.
It's Cinco de Mayo. We're talking about salsa. What a coincidence. That's synergy right there.
I think this is kind of why I mentioned sort of all of those like news articles at the beginning, all the attacks. I think the thing is like, it's sort of just something you have to protect yourself against these days. Like it's becoming more and more common, and you don't really want to be the person to end up in the news. So to be honest, like it's sort of one of those things where it's like attacks you're always at risk of attack, and nobody's perfect. Like you can never perfectly secure your supply chain, but you can do your best to secure it, and you can at least try and do, like, it's literally just that you can try and do the best that you can. And so at least if you can look back and you can say like, oh, at least we achieved this salsa level. We did what all of kind of our peers were doing. It's more so that you just got unlucky and less that you were negligent.
Yeah, I think there's a counterintuitive idea here, which is, we think that there's this fundamental trade-off between you're working on security and reliability versus the productivity to ship features. But I actually think putting in fundamental infrastructure around supply chain leads to better productivity for the engineers anyway. If you have people who build these kinds of systems, you look at the top levels of these of the performance of this, you're going to have repeatable builds that are going to generally have higher quality. You're not going to have as many build breaks and issues that are facing you. Probably get your unit tests in place. All the things that actually lead to higher levels of engineering efficiency and productivity anyway. Like so much tech debt, which, all these security reliability issues are a form of tech debt that the team is dealing with. And a lot of it slows people down anyway. So I think there isn't necessarily an either or is one thing to position. And the second thing is, as a company, not shipping a feature as fast as a competitor might hurt you and slow you down. But to Priya's point, ending up in the news for a privacy disclosure, cryptocurrencies happening on your machines, any of these kinds of real issues, like these are existential issues. And I think this is the big thing to think about, is that there's, you may have to slow down incrementally to avoid an existential risk. And this is what I think smart companies are doing now. Smart leaders are thinking about, our business is primarily digital. Data wants to be free. People are trying to get it. And we have to be smart about our privacy practices. We have to be smart about our security practices. This is not something that you can just kind of, hope for the best. You got to actually take advantage. Hope is not a strategy here. So if you
if you make the lives of the engineers easier by going through this process, it's going to be used. If you make it more difficult, they're going to find lazy ways around things just to be productive. But the overall high level strategy is what's important to keep in mind.
I think that's right. Yep.
Awesome. Okay. Well, I learned a lot. I don't know, are there any other questions from people still on the call? I don't see anything in the questions in chat. No? All right. Well, I think we can close it out. This has been great. Thanks, Priya and Kit, and really appreciate it. And this is obviously being recorded, so we could refer back to it later. But thank you very much.
Thanks, Sean. Thanks, everybody. Thank you, Nearform. See you at SlowConf.
See ya.